We just completed the chapter, and with that, we must have completed around 70% of the language basics. In this chapter, we studied about the core building blocks of a method, like operators and control flow statements, which are useful in building meaningful logic. We also looked at variable scoping rules, which define where in the program a particular variable can be used. Now let's look at some of the important points we covered in this chapter. We began with arithmetic operators, which are applicable only on primitive numeric types. That is, they apply to all primitives except Boolean. One exception was plus operator, which can also be used for concatenating strings, which we will look at while discussing strings. We also looked at few important rules that may come into play when using arithmetic operations. First one is operator precedence rule. It is useful when an expression involves multiple operators and the order in which operations should be applied is not clear from the expression. In this case, two rules could be applied. First rule gives preference to multiplicative operations over additive operations. Second rule is that operators within the same group will be evaluated from left to right. Next rule was operand promotion rule. And according to this rule, operands smaller than int data type are promoted to int. Third rule is that if both operands are of same type, then the final value of the operation will also be of the same type as the two operands. Final rule says that if both operands belong to different types, then the value of the smaller type is automatically promoted to larger data type. These rules are very important, especially the last two. Sometimes developers are not aware of these rules, and consequently they are never clear on why certain arithmetic expressions produce certain results. Next, we looked at comparison and logical operators. Comparison operators compare one operand with another, and they are also referred to as relational operators. There are several comparison operators, but if you want to check whether two object references reference the same object or not, then we can use equal to and not equal to operators. These operators are also useful for performing null checks and avoiding runtime errors like null pointer exception. Logical operators are useful if we want to test multiple conditions to perform some action. And among the logical operations, and or operators are short circuit operators. Next, we looked at bitwise and bit shift operators, which operate at bit level. You may never use them unless you are doing some low-level complex programming work. Both of them are especially useful in resource-constrained applications. Bitwise operators operate on only integer and Boolean primitives. Their use with Boolean is pretty rare, and so they are mostly seen with integer primitives. Bit shift operators, on the other hand, operate only on integer primitives, and they shift bits on either right or left direction. Left shift operator corresponds to multiplication by powers of 2, while unsigned right shift operator corresponds to division by powers of 2. Such bit shifting is much faster than performing multiplication and division, and hence they are useful where performance is critical. And here are some applications of these operators. If you recall, we discussed that Java uses these operators in its hash map data structure, which is an implementation of hash table. Specifically, it is used in something called hash function. Hash map and hash tables will be discussed when we are covering data structures. After operators, we looked at control flow statements, and switch statement was one of them. One important thing about switch is that the switch expression, which is used in parentheses, has to be an integer, string or enum, so it cannot be anything else. And one important question we addressed was when to prefer switch statement over an if statement. And here are some possible reasons for you to consider using a switch. One reason is if it improves code readability. Next is intent. That is, by using a switch, programmer is deliberately making a statement that only one variable is involved. Finally, speed. Due to the way it is internally implemented, switch is faster than if. If there are too many conditions to test, then you may want to use a switch. You can use a profiler like JProfiler, and it can help you in making this decision. We also looked at a recommendation from Effective Java, and it is item 46, and it said prefer for each loops to traditional for loops. For each is specific to iterating data structures like arrays. It provides a cleaner syntax as it hides some of the expressions used in a traditional for statement, like the condition expression and the expression list parts. This also reduces opportunities for errors. So don't use traditional for loops unless you need access to the index variable. Finally, in general, prefer for loops over while loops. This is also recommended by one of the Effective Java items, and it will be discussed later. And that's about it. Thanks for listening, and we will continue learning more language basics in the next chapter. So see you in the next chapter. Thank you.